Now let's work on a few more examples. Examples 2, 3, and 4. These three examples are based on example 1. So we use example 1 as a base model. We make some change to see what will happen. So first of all, let's open example 1. So this is a file. As I said, for any arena models, the file extension DOE. So let's open this file. Click example 1. Make sure you choose the right folder. So choose example 1 and open it. This is that one we just did. So I'm going to run simulation. This time I don't want to see the animation, so I can run quickly. I slide the bar to the right. So one thing I wanted to remember is that the waiting time. So for this particular MM1 model, the average waiting time is about 32.9 minutes, so roughly about 33 minutes. So with MM1, with average in arrival time 10 minutes, average service time 8 minutes. So the average time each customer has to wait is about over half an hour, so 32.9 minutes. I wanted to remember this number because later when we do examples 2 and 3 and 4, we need to compare the waiting time for those examples with this number, so to see whether it's going up or it's going down. So 32 minutes. So I'm going to close it and a simulation. So this is example 1. So let's work on example 2. So example 2, what we need to do is just to save example 1 as example 2. So I don't have to start from scratch. I use example 1 as a basic model and make some edits. So I save example 1 as example 2. Pick a different name. Save it. Now we have example 2. So in example 2, everything is the same as example 1. The only difference is that we are going to hire one additional bank teller. Because in example 1, the average wait time is about 32 minutes. So customers may not be happy. So the manager decides to hire one more people, try to reduce the wait time for customers. So let's think about it. For a second model, it will be MM2 because we have 2 bank tellers. So it will be everything the same, distribution, arrival, process, service process, the distribution the same. You don't want to make any change. The only difference is we are going to have 2 bank tellers. So imagine with 1 bank teller, the average wait time is about 32 minutes. So what will happen? In your opinion, what will happen if we hire 1 additional bank teller? With 2 bank tellers, what will happen? Some people may say with 2 bank tellers, maybe the wait time will be half, maybe 16 minutes. Is that true? We don't know. We'll have to run simulation to find out. So let's do this. So this is our original example. Now we need to add 1 more bank teller. So we need to specify there will be 2 bank tellers. So remember when we did the process module, we had a bank teller. We defined a bank teller. The quantity is 1. As I said, this is not the place. This is not the place where we specify the number of servers. So we don't do this. Okay, this will be the same. This one means each customer needs exactly 1 bank teller to help them. So this is the one will stay the same. We don't want to make any change. So how do we change the capacity? In other words, how do we change the number of servers? We go to the project bar, you will see resource because bank teller is a resource. So we click resource. So once you click resource, you go to here, go to the bottom, you will see here a list of all the resources we have defined so far. So for this example, we only have 1 resource, which is a bank teller. So resource bank teller, what's the capacity? So right now it's 1, the capacity is 1, that's the default capacity. We want to hire 1 additional people, so we want to change it. Double click, type 2. So now we have 2 bank tellers. Okay, so that's how we change the capacity. We save it. Okay, now we have 2 bank tellers. We run simulation to see what will happen. Simulation runs pretty quick, so we can click yes. We want to see the report. We can look at different information, but here one information we're particularly interested in is the wait time. The wait time now is, look at this number. The average wait time is 1.2 minutes. So some people may feel surprised. With 1 bank teller, the average wait time is about 32 minutes. With 2 bank teller, it's not half, it's much less than half. It's about 1.2 minutes. Okay. So without simulation, there's no way you can figure it out. So that tells us if you hire 2 people, there's almost no waiting. Okay? So this is about example 2. So let's close it. Let's end the simulation. Save example 2 and close it. Now let's work on example 3. So example 3 is also based on example 1. So what we're going to do is open example 1. Example 1, open it and save as example 3. So for example 1, it is MM1 Turing model. So that means customer in arrival time follow exponential distribution, and the service time also follow exponential distribution. In this case, we're going to reduce the variation of service time. So in example 3, we'll see what will happen. So right now, for both customer arrival process and service process, both follow exponential distribution. That means both time has variation. So right now, what we want to see is what will happen if we fix it, one of the 2. So for example, in this case, in example 3, we're going to fix the service time. So reduce the variation for service time. So see what will happen. So arrival process stay the same. We don't want to touch it. Service process, in example 1, it follows exponential distribution. So it has a variation. So in example 3, we make it fixed. So we fix the service time. See, to serve each customer, it will be exactly 8 minutes for each customer. No variation to see what will happen. So how do we change it? So everything stays the same, but here, delay type. It's no longer exponential distribution. We make it a constant. Okay, constant means fixed. Constant, minutes, how many minutes? 8 minutes. So average service time will be the same, 8 minutes, but no more variation. So it will be constant. So it's constant 8 minutes. So this is how we're going to change it, example 3. Okay, so everything else the same. The only difference is now we no longer have variation for service time. So 8 minutes constant. Click OK, save it. Now we run simulation. So before we click run simulation, what do you think? Do you think by reducing the variation for service time, do you think the average wait time will be longer or be shorter? So based on theorem, we know if we reduce variation for service process, the average wait time will be shorter. And how much shorter? We can find out by running simulation. We can see the report. So remember, with in example 1, with variation on both service time and in arrival time. So when both have a variation, the average wait time is about 32 minutes. So now the service time no longer has variation. So what is average wait time? So average wait time, you can see it's shorter. It's more than half. It's less than half. So it's about 14 minutes. It was 32 minutes. Now it's 14 minutes, much shorter. So one way to reduce average wait time, now we can see, is to reduce the variation for service time. So this is by example 3. Okay, pay attention to this number. So close it and end the simulation. Save our example, and then we can close it. Now we do example 4. Example 4 is the opposite. So the service time will stay the same, will be exponential distribution, but for in arrival time, we are going to fix it, okay, to see what will happen. So we open example 1, and then we save it as example 4. So we start with example 1. We save it as example 4. So as I said, the service process will be the same. It will be exponential distribution with average 8 minutes. We don't want to touch it. We want to change the in arrival time. So in arrival time, we no longer want exponential distribution. Instead, we want to have a constant. So we want to have a constant 10 minutes. This means what? The in arrival time will always be 10 minutes. So customer will arrive every 10 minutes. So it'll be exactly no variation. So click OK. Everything else stay the same. So now service time has variation, in-arrival time has no variation. What will happen? We may expect that the average wait time will reduce as well based on a theorem. How much can be reduced? Let's run simulation. It was 32 minutes. Now it's about 12 minutes, less than 13 minutes. Okay, much shorter, much shorter. So that confirms our theorem. End the simulation, save it, close it.